It certainly captured the imagination and made headlines around the world. The announcement in September of the discovery of phosphine in the clouds of Venus, and the tantalizing possibility that this gas could be produced by life.
We're here at the Royal Observatory Greenwich, where we'll be reporting on the reaction to that fantastic discovery and finding out from the team what are the next steps in the exploration of the clouds of Venus.
Venus still seems like an unlikely place to look for life, so we'll be finding out where else in the solar system we should be searching.
We'll be giving you the latest information on missions to Mars and some of the icy moons of the gas giants.
And Pete will be telling you where to look to catch the two most spectacular meteor showers of the year.
Welcome to the sky at night.
In September, we brought you an exclusive report from the Cardiff-based team
It has been very odd.
who had discovered the gas phosphine in the upper atmosphere of Venus. I can't believe I get to say that to camera.
That kind of blew me away.
I was just stunned.
Something which might just turn out to be a sign of life.
Bacteria surrounding themselves by something tougher than Teflon.
Penguin poo in the upper atmosphere of Venus.
The discovery certainly caused a stir.
Perhaps there really are these floating microbes.
On Venus, there's something seriously weird going on.
Setting scientists scurrying to react to and argue with the results.
Optimism, despair, optimism.
To get the inside story of the global reaction, I had a catch-up with Emily Drabeck-Maunder.
Well, Emily, last time we talked was just before the announcement of phosphine on Venus was made. And how have the last few weeks been?
Pretty overwhelming, but it's been particularly exciting to see how excited the public is about the discovery. I think our work really taps into this universal longing that we all have for there to be life out there in the universe.
What's the reaction been like from your colleagues, from other scientists?
I think it's always really nerve-wracking when you put out a paper. It's always a possibility that one of your colleagues will come along and show that what you've done is wrong. But in general, I think that's also the nature of science. We're all working towards understanding our universe. But I've been particularly excited and interested in some of the studies that have actually gone back to old observations to look at them with new eyes.
So there was an exciting new result, but from old data from Pioneer Venus. Tell us about that mission.
Yeah, so the Pioneer Venus orbiter was operational between the 1970s to the 1990s, and it was studying Venus's atmosphere. And so the team that put out this study wanted to go back and look at those observations to see if they might have missed phosphine gas. They were able to find a signal that is consistent with phosphine in the parts of the atmosphere that is actually consistent with our study.
And so this discovery that you made was sitting in this data all this time, but no one had thought to look for phosphine.
Exactly.
What about other spacecraft visiting Venus?
So Bepi Colombo is actually on its way to the planet Mercury, but it's going to fly past Venus a couple of times before it reaches its final destination. It just flew past Venus yesterday, but it's going to be even closer next summer. Bepi Colombo has the ability to look for phosphine using infrared light. And that's really important because we can actually pinpoint the location that phosphine is coming from in Venus's atmosphere.
What about telescopes here on Earth? If we want more data now, we have to go back to the telescopes. Have you managed to do that yet?
One of the things that we're doing is doing a long-term monitoring project where we're going to be looking to see if phosphine changes over time in Venus's atmosphere. And just by looking at how phosphine gas changes over time, that can give us a better idea for what might be causing the phosphine gas. Now, also, we can look for phosphine, again, in infrared with SOFIA. And the SOFIA infrared telescope is actually on board a plane that flies around over the course of a night, and it can look for phosphine.
I recommend Sophia. We've flown on it for Sky at Night and it was an amazing adventure. Ready for takeoff? So if you can use that to look at Venus, that would be fun.
Really, what we need to do, if we want to understand Venus's clouds and what is causing this phosphine observation, we really need to send spacecraft out to Venus with an instrument on board that is astrobiological in nature. So that would be searching for life.
Since we caught up with Emily, 3 separate teams have released papers online casting doubt on the result, criticising the techniques that were used to process the data.
Alma Observatory also, separately, says there might be a problem with their handling of the data, and they're looking into it.
This sort of argument, criticism and reanalysis is cutting-edge science acting exactly as it should. But so far, the Cardiff team are standing by their discovery, and of course these critical papers will need to be formally reviewed themselves.
It seems likely that the dispute will be resolved only by pointing the telescopes back towards Venus, something that should happen in the first half of next year.
Despite all the excitement around the discovery of phosphine in the upper atmosphere, Venus still remains a very inhospitable environment. The best habitats that can potentially support alien life within our solar system lie in the opposite direction, away from the sun, in the icy moons of the gas giants, or that old favourite, Mars. To get the latest on our search for life on Mars, I spoke to astrobiologist Louisa Preston. Hi Louisa, lovely to speak to you. Now, you're an astrobiologist, which sounds pretty cool, but what do you do as an astrobiologist?
So an astrobiologist is somebody who is looking for life on other worlds. Whether they're doing that through chemistry or through biology or through geology or astronomy, whichever different subject they're using, they're trying to identify evidence that life once existed or maybe currently exists on other planets and moons.
Now, I'm sure you've heard about the discovery of phosphine in the outer atmosphere of Venus. What do you make of this? Do you think this is a sign of life, or do you think other?
I have to be honest, even as an astrobiologist, and I have a lot of faith and hope that there will be life found somewhere, I'm not convinced that there's life in the atmosphere of Venus just yet.
And so do you think the environment is just too severe for life to exist?
Venus is sweltering hot, extremely high pressures, full of sulfuric acid. If we went, we'd be cooked, squashed and melted all at the same time. It's a terrible environment.
So as you look out there into the universe for life, how do you think we should do it? Should we sort of home in on sort of the unlikely environments and then look for life?
I think we have to look for what we understand. So we're looking in environments that resemble those environments we find on the Earth. So planets or moons that are in their habitable zones of their stars or their host planets, you know, just in the right conditions where liquid water can be stable, where we know there might be organic molecules that life could use. They're not too bombarded with radiation. There might be a nice atmosphere to protect them. Little things like that, and I think that's what we have to look for.
But by doing that, are we looking for life as we know it?
I think yes, we are, at the moment we are looking for life as we know it, but we are aware that we could be wrong. And so there are scientists who are focusing on alternative chemistries or alternative metabolisms and different ways that life could work, just so that we don't miss something when we are looking around another world.
So as we do look out there, where do you think the best places that we should be looking are at the moment?
Obviously Mars. Mars is a very popular world. We've got one mission there looking for habitable environments at the moment. We've got Perseverance on the way. We've got the ExoMars Rosalind Franklin rover going in 2022, and they're all looking for signatures that life may once, maybe even now, but probably more likely once lived on Mars. But we can also look at moons. We're very interested in the moons of Jupiter and Saturn, such as Europa, Enceladus and Titan.
Let's start with Mars. Perseverance will land on Mars in 2021. How's it going to go about looking for signs of life?
What it's going to do is it's going to study different rocks and minerals that it finds in Jezero crater where it lands, that we know are very good at preserving the biosignatures of life. The other thing that Perseverance is going to be doing is preparing for Mars sample return. So it's going to be collecting samples in the different locations it's going to and leaving them all packaged up and ready for a future mission to come and pick them up and bring them back to Earth. And then we can really attack them with all our really good instruments that can't be quite miniaturized for a rover yet.
We've been sending a lot of probes to Mars. We've been searching for a long time, but we haven't discovered anything yet. What does that tell us?
I think it tells us that life isn't sitting on the surface waiting to be found. So we know Mars in its history was a habitable world. We can see evidence that there were rivers and lakes on Mars. But the world changed. It lost some of its atmosphere. It became much colder, lower pressure, and the liquid water vanished. So any life, if it was there, either became extinct or it had to evolve and quite possibly go and hide underground. So what we want to do is look under the surface of Mars, and that's something that most of our rovers so far haven't been able to really do to a great depth. And that's what the ExoMars Rosalind Franklin rover is going to do. She's going to be able to drill 2 meters into the surface, and hopefully, if there's anything hiding down there, we'll be able to find it.
So if we do find something, what would be the key indicators that tells us that there is life on Mars or there was life on Mars?
Well, I mean, if we're really honest, a bone or something wiggly looking, I think what everyone would love to see. But in all honesty, we will find a molecule or a fat or an amino acid or something that goes into making a protein. It will be a chemical signature, which won't look very pretty, but it will definitely prove that life was once there.
So if we did find life, as an astrobiologist, what effect would that have on you? And what effect do you think you'd have on humans across the world?
I think to know we're not alone and to know that life isn't just this unique thing, it's everywhere, I think would be absolutely fundamental. Scientifically, I think it would be incredibly interesting. We don't really know how we came to be. All the history of how life started on the Earth has been erased because our planet is so geologically active with our earthquakes and our tectonics and our volcanoes. So that's why we like to look at Mars, because it's all preserved there, because it hasn't had the same geological processes. So if we found life there, it could fill in all the gaps for us and maybe help us understand so much more about where we came from.
Okay, that's enough talk about probes, maybe aliens, and maybe life. Let's get back to some real observing. Or rather, I would if it were clear. The forecast was for clear skies, but it has sadly clouded over, which is a real pity because tonight is the peak of the Orionid meteor shower. Of course, by the time you're watching this, the Orionids will be over. But there are 2 really good meteor showers I want to tell you about, which are going to occur between now and the end of the year. The first is the Leonid meteor shower, which peaks on the 17th of November. Now that shower produces really swift meteor trails, which appear to come from the head of Leo the lion, among the swiftest meteors that we get throughout the year. And the rates aren't particularly wonderful for the Leonids, anywhere from 15 to 20 meteors per hour under optimum conditions. But that's not the case for the Geminids. Now this one peaks in the early hours of the 14th of December, and the 14th is when the moon is new. So I'm really excited about this because the Geminids have a peak zenithal hourly rate, typically 140 to 150 meteors per hour. These meteors enter the atmosphere at about half the speed of the Leonids. So they're much slower, they're much better for photography, and you often get really bright events. Okay, so the equipment you need to observe meteors is pretty simple. You just need your eyes. You need to make sure that you have been in darkness for at least 20 minutes to give your eyes time to adapt to the dark properly. Make sure you don't use any bright lights after that because you'll destroy your dark adaptation really, really quickly, so put those mobile phones away. And then you need to make sure you wrap up warm. November and December are pretty chilly, and have something which is comfortable to lie in. Something like a deck chair or a garden lounger, or here I've got my trusty hammock. Typically looking up at a height of about 60 degrees is ideal. And just relax, look up at the sky, take in the view, and hopefully you'll see some of those meteors streaking across the heavens. Another side of observing meteors is to try and photograph them. But you do have to work hard at it, and it's fairly common to end up with thousands of pictures of nothing more than the stars in the sky. Now, the best type of camera to use is one with a lot of manual controls on it. Pre-focus it at infinity, open the lens fully to the lowest f number. With the ISO on the camera, set it fairly high. If it's a modern camera, anywhere up to about 10,000 should work. And typically, what I would do is set the camera to do continuous exposures, so it takes one picture after the other, and then use a shutter release cable. Lock the cable down so the camera thinks you've constantly got your finger on the shutter button. That way it'll just keep taking picture after picture. So if you set your exposure to, say, 30 seconds or so, then you'll get lots and lots of 30-second exposure shots. And then just let it run throughout the course of the night. Keep checking the front of the camera because the lens can mist up, and also check the battery, of course, because that can run out. So that's all there is to it, really. And then just take loads and loads of pictures, look through them the next day. That's quite exciting. And if you're lucky, you'll get a nice picture of a meteor trail running across the sky. So with that, all that remains for me to say is good luck. Good luck.
Meanwhile, back to the hunt for the solar system's most likely venue for alien life. Maggie's been talking to Lee Fletcher about ESA's upcoming JUICE mission to the icy moons of Jupiter.
Hi Lee, lovely to speak to you again. And I wanted to get the ball rolling by talking about the discovery of phosphine in the atmosphere of Venus. I'd love to get your views. Do you think it's an indicator of life?
I'm not entirely convinced just yet. I think there's so much we don't fully understand about the chemistry of the atmosphere, the interaction with the surface, and the volcanism that might be taking place on that world. But I'm prepared to be astonished and prepared to be amazed.
Where else in the solar system do you think we should be looking?
I personally believe that the best place to go to look for evidence of habitable conditions are the icy moons of the outer solar system. Somewhere like Europa, for example, the moon of Jupiter that's tantalised us for generations. Now, we've been searching for evidence of liquid water across the solar system, and Europa has it in spades, probably twice as much liquid water on Europa as there is in all of the oceans on planet Earth itself. And compare that with somewhere like Mars, where we've been continually searching for evidence of liquid water, and it's been very hard. Europa, Enceladus, Ganymede, and all of the rest of those icy satellites, I think, are the places to go to look for evidence of habitability.
Speaking of Enceladus, the fact that Cassini found all that water and also jets are spurting out into space, is that a game changer in terms of where we look for life?
I think the really important thing about Enceladus was how we didn't expect this tiny little icy moon of Saturn to be quite as interesting as it was. It had these fissures located on the South Pole with these geysers of liquid and gaseous material coming out from the interior. That's where nature truly is conspiring to give you access to the material that's on the inside. And that's the holy grail for us. We want to sample the conditions, the material, the chemical composition of those deep, dark, hidden oceans.
So what is happening in terms of research out there? And can you tell us more about JUICE, a mission you're working on?
So the JUICE mission, the Jupiter Icy Moons Explorer, we're only about 20 months away from the launch of this mission, which is quite an incredible thing to think about. And ultimately, it's going to be the first ever spacecraft to go into orbit around an icy satellite, Ganymede, the largest moon in our solar system. Now, the key goal of JUICE is to understand the emergence of potentially habitable environments around gas giant planets, to extend what we might traditionally think of as the habitable zone out beyond the confines of the Earth and the terrestrial planets into the more distant, cold, icy realms of the solar system. Because there, instead of sunlight providing you with that energy source you need to keep water in a liquid phase, instead you have tidal heating. The moons of Jupiter and Saturn are constantly being flexed and kneaded by the powerful gravitational field of the gas giant itself, and it's sufficient to keep the insides of these satellites as hidden oceans of liquid water.
You mentioned that JUICE is 20 months away from launch, and I think it's going to take over 7 years to get there. But when it does and it starts getting data, what would be your yip yip hooray moment? What would you like it to discover?
I think that potentially the most exciting instrument we've got on board is an ice-penetrating radar. And what that's going to be doing is sampling the subsurface of these icy moons, down to potentially depths of about 10 kilometres below the surface itself. Now that means we've got the tantalising prospect of mapping the interface between the watery ocean and the icy crust itself, and potentially detecting things like subsurface pockets of water that might be feeding those plumes themselves. So I think in just over 10 years' time, when JUICE is orbiting Jupiter and taking these wonderful observations of the icy satellites, it'll be those subsurface measurements that I'm particularly excited about seeing.
So where's your money? Where do you think there is life in the solar system?
I like the idea of some of the moons.
Whenever people say this might be aliens, it's never aliens in the end. But at some point, it's going to be.
I have hope. I think we will find life out there. And I think life is probably more prevalent than we think. But I just feel we're very limited by being here on Earth. I want to go out there.
Yeah, with a hammer.
Digging in the rocks, sledgehammering everything.
This is why Enceladus is good, because you can fly through the plumes. It's weird we don't have an Enceladus mission on the books. While discussion continues as to the most likely place to find alien life in the solar system, there's one more mission being planned that's a particular favourite of mine. Dragonfly, a quadcopter mission to Titan. Sarah, lovely to see you. When we were talking about life in the solar system, I knew we had to talk about Titan, and that's your territory. Why is Titan an exciting place?
I mean, why isn't Titan an exciting place? It's at least in the present day solar system, the most Earth-like place that we have. It's the only body besides Earth that currently has liquids on its surface. And so we have lakes and seas, we have rainstorms. Of course, the liquid is very different, right? Titan's extremely cold. And so rather than having liquid water like we have here on Earth, we have liquid methane and ethane. And liquid's very important because we think that it's a requirement for life. And so this is one of the reasons why we're so interested in studying Titan.
Titan's liquid secrets were first revealed in detail by the probe Cassini and its landing partner, Huygens. At first sight, Titan's a boring orange fuzzball of haze, but Cassini-Huygens managed to break through the fog, first with Huygens' historic landing on the surface, and also with Cassini's haze-penetrating radar, which revealed a fascinating and complex surface with lakes, seas, rain, and dunes.
Cassini-Huygens really revealed this incredibly complicated world with a methane cycle that's analogous to the water cycle here on Earth.
What sort of chemistry is happening on the surface?
So we know that the atmosphere makes complex organic molecules through processes that are driven by light from the sun. That material ends up on the surface where it might end up in the lakes, and there might be subsequent chemistry there. It has a lot of geologic processes operating on it. And so we have dune fields that are made out of organic sand. And that's one of the reasons why we're so excited to go back with Dragonfly, because we want to answer those kinds of questions. What are those molecules on the surface? What does that mean for the possibility of life on Titan?
Well, I'm glad you mentioned Dragonfly, which is this amazingly wonderful mission that you're working on. Tell us from the beginning what Dragonfly is and what it's trying to do.
So Dragonfly is NASA's Next New Frontiers mission, and we'll be going to Titan with what we're calling a dual quadcopter or a rotocraft lander. It's about the size of a car. And what's so exciting about it is that it's relocatable. And so we'll go to one place, we'll land, we'll do science there, and then we can pack up and fly somewhere new and do more measurements again. And that's really important because the surface of Titan is so diverse. And the other thing that is really great about Titan is that because it's small, its gravity is low, but it has this very thick atmosphere. The density of the atmosphere is about 4 times that of Earth at the surface. And so it's very easy to fly there. If you were there yourself personally and strapped wings onto your arms, you could flap them and fly under your own power. And so we're taking advantage of that. What we're really trying to do is not just measure the composition of the surface and look for complex organic molecules, potentially signs of life, but to be able to put all of that into context to understand how Titan works as a world.
Can you just remind us what organic means to a chemist? Because we're talking about life and then we're talking about organic molecules.
In the context when we're talking about it for chemistry, what we usually just mean is that it has carbon in it. So carbon-containing molecules that, may or may not have anything to do with life.
Carbon creates complex chemistry, though. That's the point, right?
Carbon is particularly interesting, I think, for 2 reasons chemically. So one reason is it's relatively abundant. And so if you want to build a bunch of things, including life, you want the material to be readily available. And then the other thing is it's able to make 4 bonds. And so you can build all different kinds of structures. So if you were to think about a Lego, if you had Legos that only have the 2 little pins on them, you can't build as many things. But if you have the Legos that have all of the different ones, there's all kinds of structures you can build off of that. That's one of the reasons that carbon is so interesting chemically, and also probably why life on Earth is based on carbon.
And so Titan has the toy box, right? You've got this complex chemistry, and the question is whether you can add it together. What would life on Titan be like? Are we talking about squids swimming through the methane, or are we talking about little bacteria?
I think if there was life on Titan, it would make sense for it to be carbon-based. It would most likely use methane or ethane as a liquid. Because of the very cold temperatures, which slow chemical processes, which would probably result in a very slow metabolism, we're talking about probably things that would be very small.
And Dragonfly, in theory, launches in 2020. What's the timeline?
We were supposed to launch in 2026, but because of a lot of the impacts of COVID, NASA has recently asked us to move our launch date. So we think we're going to launch in 2027.
It's such an exciting mission. I think just the idea of something flying around Titan is so exciting.
Welcome to the Sky at Night.
In January 2021, we'll be presenting our pick of the year.
Mercury, Venus.
Welcome back to Earth. We made a bit of a mess while you were gone.
Yeah, no kidding.
Bringing you the best moments from the Sky at Night 2020.
That's amazing.
If you'd like a chance to appear on the show and introduce your favourite moment of the year...
Lucy,
Hey.
Lucy, okay.
Then email us at skyatnightqt@bbc.co.uk, telling us what you have chosen as your favourite moment and why.
Good luck, as long as I don't fall out.
Next month, we'll be at the Institute of Astronomy in Cambridge for a 1-hour special looking at the state of astronomy.
With some special guests, we'll be asking how far we've come in the last 10 years.
And where we might be going in the next decade.
Good night.
Follow the epic stories of NASA's Apollo missions, 13 Minutes to the Moon on BBC Sounds, and see our planet from a whole new perspective, Earth from Space on BBC iPlayer.